Hello friends, welcome to the class of 5th semester Polymer Technology. Today we'll see the topic colorants. There are basically four methods used for coloring polymers. So there are actually four methods, and namely number one, surface coating, which is painting. So we all are familiar with painting. Then number two, surface dyeing. Number three, introduction of color forming groups into the polymer molecules. And number four, mass coloration. Surface coating involves extra processing and can substantially increase the cost of the product and is avoided where possible, except in the case of fibers. So you can see that surface coating is a expensive method, so it is avoided. Then surface dyeing can be of limited use with some polar polymers such as nylons, where only a small quantity of material is required to be colored. So surface dyeing has a limited use. Then academically interesting, the deliberate introduction of chromophobic groups is an inflexible and expensive method. So if you are adding chromophobic groups to the polymer, then the polymer becomes expensive. So it is also not that much use. Therefore, the fourth method of coloring polymers is widely used. For most application of rubber and plastic, the mass coloration approach is favored. Colorants are sometimes divided into two classes: insoluble colorants, which includes pigments, and soluble colorants, which are dyestuffs. It should be, however, be noted that many colorants have low but finite solubility, so that a rigorous classification can be misleading. So because of this solubility, classifying between dyestuffs and pigments is quite tough. As explained previously, such a low solubility may, in certain circumstances, lead to blooming. Blooming is nothing but an outward growth which looks bad. One way of reducing blooming tendency is to use colorant of high molecular weight. For a material to be successful colorant, For a material to be successful colorant, it should meet all the requirements. For example, to be efficient, they should have a strong covering power. Although in some circumstances, a colorant of lower covering power than another might be favored if it was so much cheaper that more of the colorant could be incorporated and still lead to a cheaper compound. So depending on the economic factors, you can choose it. Stability to processing covers not only the obvious aspect of heat resistance, but also resistance to shear. So the good colorant should have heat resistance and also shear resistance. Particles of some colorants break down under intensive shearing and as a result may change color. When colorants are added before polymerization, they should not interfere with the polymerization reaction, nor should they be affected by the presence of some of the polymerization additives. So they should be like more or less chemically inert while taking part in the polymerization reaction. Blooming and bleeding can both be problems. Bleeding is like excess of color. Some colorants may also adversely affect polymer properties such as oxidation resistance and electrical insulation behavior. So these two properties are also sometimes get affected by colorant, that are electrical insulation and oxidation resistance. Anisotropic pigments may become oriented during processing to give anomalous effects. So anomalous is a disturbed behavior, and anisotropic means having a physical property which has a different value when measured in different direction. An example is wood, which is stronger along the grain than across it. And anomalous is different from what is normal. Okay, so this is all about colorant. Thank you.